In this video, we're going to look at an alternative formula for an area of a triangle, in particular when the when the altitude, the height is unknown, or area using trig. We know certain things using trig, in particular, if you want to think of side angle side from geometry, if you know two sides and the included angle, then you can find the area of a triangle. Okay, really what you're doing is you're finding the h without necessarily finding h. All right, let's take a look here. So I use this representative triangle often, just it's random, right? ABC. And I do want to point out that even though I drew like in a acute triangle, oblique, all sides are different. Like we don't really know, right? Kind of looks isosceles, but we don't know. Even if this were an obtuse triangle, A, B, C, or a right triangle, usually we let C be the right angle. Okay, this process would still work, and I'll demonstrate why, but let's first look at the generic first triangle I drew. Okay, so the area of any triangle is 1/2. Now when I write B, I don't necessarily mean this B, right? Like when we form the sides of a triangle, we say capital A and then across from that corresponding side is A, little a, and then B, B, C, and C. I'm not saying that little b, this B stands for base, okay, the base, and then times the height, so B is the base, H is the height. Remember that the base and the height always meet at a right angle. Now sometimes, like depending the orientation and what you know of a triangle, the height actually may not even be part of the triangle. For instance, the obtuse triangle I drew, if you called this side AB the base, right, to meet the opposite vertex, that angle at a right angle, I cannot draw a line from this base up to C at a right angle. So what we think of is extending this base and then drawing that, that right angle here. Okay, this is the height. If we used that side length AB as the base. Okay, so it all depends on orientation, because again, even in the obtuse, if you knew this length BC, which we'd call little a, right? If you knew this length, let me change colors. If you knew this length A and called this the base, now this is the height, right? The base and the height always meet at a right angle, but sometimes you do have to extend that base out for an obtuse triangle in that second one. For a right triangle, okay, it wouldn't matter if you called this the base, AC or BC, right? One is the base, one is the height, because they meet at a right angle. And you could, but usually, right, you have everything you need in a right triangle, but you could in fact call that the height, and then you know this is the base. So it all depends on orientation and what's given. All right, back at it. So the A, that again, not to confuse you, it's not the angle A, it's the area, right? Area of any triangle is half the base multiplied by the height. All right, so let's stick with, okay, we are going to use this as our height. our h, our height, that perpendicular from the vertex C down to the side length C. If that is the case, then I know that this area is equivalent to 1/2. The base here, right, is C, and then times the height. But say you don't know the height, but say you know angle A, for instance. Okay. Again, it all depends what you know, but I'm claiming two sides and the included angle. So if I knew the base C, and say I knew this length B and the included angle A, right? There's, from geometry, side, angle, side. I'm not marking congruent, I'm just saying I know this and I know this, all right? Well, H can then be expressed using sine of A. So let's do some scratch work here. I know that sine A equals opposite H, right? I'm looking at this left triangle, H over B, opposite over hypotenuse, which means H is B times sine A. So therefore, the area of the triangle, without directly finding H, right, we just have this new formula. Let me plug that in. 1/2 C times B times sine A. Notice, like, if I know the angle A, then I know the other two sides BC, right? And usually we write it in order, but it really doesn't matter, right? 1/2 BC sine A. Well, what if you knew instead, like, the other side? So let me just redraw that because it's getting crowded. A, C, C, B, B. Okay. So again, draw that height. But what if you knew B instead? Let's switch colors here. What if you knew that and a little a? Again, we need a side angle side. So I know C, I know little a, and I know that included angle B. Well, then I could write sine B equals opposite, right, H, because I'm looking at this triangle, opposite over hypotenuse, A. So H is A sine B. Well, if I plugged that into that formula, half the base times the height, right, or 1/2. Remember, I still know C in this case, but instead I have H as A sine B, right? So I'm making this substitution here, times A sine B. Well, that just shows you another form of this, depending what we know. Again, I'm going to write in ABC order, AC sine B. So if you know big B, the angle B, and the two included sides, AC, then I could find the area of this triangle. And similarly, we could redraw this and get the last set. So if I know the angle C, sine C, then I need AB. It's really easy to memorize because once you know, you need all three letters, and whichever angle, you need the other two sides. Okay? Or draw the picture and it works too. I'm not going to show it for this obtuse triangle because the process is really the same. Okay, it depends what you know, but you can always draw that height, and just plug in, right, your base times the height, whichever one is your height. Base, and then the half, because that's basic geometry, half the base times the height.